June 1942, Wolfschanze East Prussia and Adolf Hitler stands before a wooden mock-up of what he believes will be the ultimate weapon that saves the Third Reich. A tank so massive and impenetrable that no Allied gun can harm it, so powerful that it can smash through any defensive line, turning the tide of a war that is beginning to turn against Germany. Ferdinand Porsche, the automotive genius who designed the Volkswagen Beetle and countless racing cars, presents his vision of invincibility. A 100-ton supertank that will carry armour thick enough to stop any Allied shell, while mounting a gun powerful enough to destroy enemy tanks from distances where they cannot even hope to return fire. Hitler loves it immediately, demanding that Porsche build not one but 150 of these monsters, these breakthrough tanks that will crush the Soviet armies threatening the fatherland, and demonstrate German engineering supremacy to the world. What Hitler cannot see, what his engineers already understand but dare not say too loudly, is that Porsche is proposing something that violates every principle of practical tank design, something so heavy that bridges will collapse beneath it, so complex that it will break itself faster than enemy action ever could, so resource-hungry that building it will drain precious steel and fuel from weapons that might actually win battles. The Panzerkampfwagen 8 Maus, ironically named Maus, will become the heaviest fully enclosed armoured vehicle ever built, weighing 188 metric tons, 3 times heavier than a modern M1 Abrams tank, and it will fail spectacularly before firing a single shot in anger, destroyed not by Allied weapons but by the impossible demands Hitler and Porsche placed upon it. The Maus project begins not with clear military necessity, but with Hitler's obsession with gigantism and his belief that bigger always means better, a philosophy that ignores the lessons German tank crews are learning on the Eastern Front, where Soviet T-34 medium tanks proved devastatingly effective, not because they are heavily armoured or powerfully armed compared to German Tigers, but because Russian factories can produce them by the thousands, while they are fast enough to manoeuvre around slower German heavy tanks. Throughout 1941 and early 1942, German intelligence reports describe Soviet experiments with super-heavy tanks, vehicles weighing 70 to 90 tons mounting heavy guns and thick armour, projects that never reach production because Soviet engineers understand that such vehicles would be maintenance nightmares, consuming resources better spent on proven designs. But Hitler sees these intelligence reports and becomes convinced that Germany must not only match but exceed anything the Soviets might build, demanding a tank that weighs not 90 but 100 tons, armed with the most powerful gun available, protected by armour so thick that enemy shells will simply bounce off like rain on a roof. He turns to Ferdinand Porsche, whose electric transmission designs have impressed him despite their failure to win the production contract for the Tiger tank, giving Porsche the contract in March 1942 over the objections of more conservative engineers who understand the magnitude of the challenges involved. Porsche's initial designs call for a tank mounting a 105mm gun with armour between 160 and 200mm thick, dimensions that seem reasonable until engineers begin calculating what such a vehicle would actually weigh and how much power would be required to move it. The tank initially designated VK-10001 Porsche, Type 205 and nicknamed Mammoth, grows heavier with each design revision as Hitler personally intervenes to demand thicker armour, a bigger gun, more ammunition storage, better protection against infantry attacks, features that all add weight without anyone asking the fundamental question of whether the resulting vehicle will be able to function in actual combat conditions. By December 1942, the project receives the designation Mäuschen or Little Mouse, a name dripping with irony given that the vehicle now weighs nearly 140 tons, and by February 1943, when Hitler formally approves production of 150 vehicles, the name shortens to simply Maus, the mouse that will crush Germany's enemies beneath 188 tons of steel. The specifications Hitler approves seem impressive on paper. Front glacis armour 200mm thick, turret front 220mm, side armour 180mm, far thicker than the Tiger's 100mm frontal armour, armed with a 128mm KWK-44 gun capable of destroying any Allied tank at ranges exceeding 3,500 metres, with a coaxial 75mm gun for good measure, protected by armour that should make it essentially invulnerable to anything the Allies can field. But these specifications ignore the brutal realities of physics and engineering that will doom the Maus before it ever reaches a battlefield. The first and most fundamental problem facing Porsche's engineers is developing an engine powerful enough to move 188 tons at anything resembling useful speed, while remaining small enough to fit inside the tank's hull, a challenge that proves nearly impossible with 1942 technology and Germany's increasingly strained industrial resources. Porsche chooses to use his favoured electric transmission system, the same design that failed to win him the Tiger contract, where an internal combustion engine drives an electrical generator which powers electric motors connected to the tracks, a system that eliminates the need for a complex mechanical gearbox but adds tremendous weight and creates countless points of mechanical failure. The initial engine selected is the Daimler-Benz MB509, a gasoline engine adapted from the DB603 aircraft engine producing around 1200 horsepower, which sounds impressive until engineers calculate that moving 188 tons requires far more power than 1200 horses can provide. During initial testing in late 1943, the first prototype struggles to reach 13 km per hour on level ground under ideal conditions, less than half the designed top speed of 20 km per hour. And even this pathetic performance strains the engine and transmission to their limits, components overheating and failing regularly as they attempt to push a weight they were never designed to move. The engine problems plague the Maus throughout its development as Porsche switches from the MB509 gasoline engine to the MB517 diesel engine for the second prototype, hoping that diesel's superior torque characteristics will improve performance. But during the second prototype's first trial in September 1944, the crankshaft breaks, leaving the vehicle immobilized and requiring weeks of repairs. Even when engines function properly, they consume fuel at catastrophic rates, the Maus carrying 924 gallons of fuel that provides a maximum range of only 190 kilometers under optimal conditions, meaning the tank burns nearly 5 gallons per kilometer traveled. A fuel consumption rate so extreme that operating even a handful of Maus tanks would require dedicated fuel supply operations in a Germany already facing severe petroleum shortages. The electric transmission adds its own constellation of problems, with generators burning out, electric motors overheating, control systems failing, steering mechanisms jamming, a cascade of electrical and mechanical failures that leave test prototypes broken down more often than they run, requiring constant maintenance by skilled technicians using scarce parts that could be better used keeping conventional tanks operational. Test reports describe vehicles that can barely move, that overheat after short periods of operation, that require 2 other Maus tanks to tow them if they break down, because nothing else in the German inventory is powerful enough to move 188 tons, a design flaw so fundamental that it makes the entire concept operationally absurd. The Maus's weight creates problems that cascade through every aspect of its design and deployment, starting with the simple fact that at 188 tons it is too heavy to cross virtually any bridge in existence, meaning it cannot use roads like conventional tanks, but must instead board rivers or find alternate routes, severely limiting its tactical mobility. German engineers attempting to solve the bridge problem create one of the war's most bizarre technical solutions, designing the Maus to drive through rivers underwater to depths of up to 8 meters, using a snorkel system for air intake, while a second Maus on the riverbank supplies electrical power through a cable, allowing the submerged tank to power its electric drive motors without running its engine and flooding the compartment with exhaust. This underwater crossing capability seems ingenious until one considers the practical implications, that it requires 2 Maus tanks working together, that it leaves one vehicle completely vulnerable while submerged, that it assumes rivers have suitable approaches and exits that can support 188 tons without the vehicle sinking into the mud, or that it requires crew members to remain inside a sealed steel box underwater, knowing that any seal failure or snorkel problem means drowning in a metal coffin. The requirement for specialized river crossing techniques effectively means the Maus cannot operate independently, but must always deploy in pairs, and if one vehicle is lost or breaks down, the remaining tank cannot cross water obstacles, cannot withdraw if threatened, becoming trapped by its own design limitations. The sheer physical dimensions of the Maus create logistical nightmares that German planners struggle to solve, the tank measuring 10.2 meters long, 3.71 meters wide, and 3.63 meters high, dimensions that make it too large to transport by normal means, and too heavy for standard railway flat cars. German engineers design a special 14-axle railway transport wagon specifically for moving the Maus, but even this custom equipment proves inadequate as the combined weight of wagon and tank exceeds the load capacity of many railway bridges and cannot pass through railway tunnels, meaning that shipping a mouse from factory to front requires detailed planning to find routes that avoid infrastructure the vehicle cannot use. The implications become clear when planners attempt to wargame how mouse units would actually deploy in combat, realizing that concentrating even a dozen vehicles in a single area would require weeks of advanced railway scheduling and specialized transport equipment that does not exist. While the tanks once delivered to the front would consume fuel and require maintenance at rates that overwhelm standard logistical systems designed to support conventional tanks. One calculation shows that supporting a company of 10 mouse tanks would require dedicated fuel trucks making constant trips from supply depots, specialized recovery vehicles to tow disabled tanks, mobile workshops with equipment to lift and replace engines and transmissions, and stocks of spare parts so extensive that they would fill multiple warehouses, resources Germany simply does not have in 1943 and 1944, as Allied bombing destroys factories and transportation networks. The testing program that begins in earnest in January 1944 reveals the Mouse's inadequacies in painful detail as the first prototype designated V1, fitted with a concrete turret mock-up for weight testing, undergoes trials at Kummersdorf, proving grounds near Berlin, where it promptly demonstrates its inability to perform basic tank functions, struggling to climb modest slopes, sinking into soft ground that standard tanks cross easily, destroying paved roads simply by driving over them, as its weight exceeds what the pavement was designed to support. Test drivers report that while the Mouse steers relatively easily thanks to its electric transmission, a surprising feature in such a massive vehicle, the low top speed and poor acceleration mean that it cannot react quickly to tactical situations, cannot maneuver to avoid enemy fire, cannot exploit breakthroughs or defeated enemies, essentially functioning as a mobile pillbox rather than a tank in any conventional sense. The armour that should make the Mouse invulnerable creates its own problems, as the 200mm thick steel plates require welding techniques at the limits of German industrial capability, with welds occasionally failing during testing, creating gaps in the armour protection, while the massive turret weighing 55 tons requires special machinery to lift and install, machinery that would never be available in field conditions where battle damage might require turret replacement. The armament that seems so impressive on paper proves problematic in practice, as the 128mm KWK-44 gun, while certainly powerful enough to destroy any Allied tank in service, comes with drawbacks that negate many of its advantages in the Mouse installation. The gun requires such large and heavy ammunition that the tank can carry only 68 rounds of 128mm shells plus 200 rounds for the 75mm coaxial gun, limiting sustained combat capability. While reloading the massive 128mm shells in the cramped turret requires two loaders working together, slowing the rate of fire to perhaps 2 rounds per minute under combat conditions. The gun's long-range capability matters little when the Mouse cannot position itself to use that range effectively, unable to see good firing positions quickly, unable to withdraw if the tactical situation deteriorates, forced to fight from wherever it happens to be rather than manoeuvring to advantageous ground. The defensive armament proves equally problematic, as initial designs lack any machine gun for close defense against infantry, the same flaw that plagued Porsche's earlier Elephant tank destroyer and made it vulnerable to infantry attack, a problem only partially addressed by adding a single coaxial machine gun that provides inadequate coverage against infantry attacking from multiple directions. The second prototype V2 completed in mid-1944 incorporates modifications based on lessons from V1 testing, including the actual turret, rather than a concrete mock-up, the new MB517 diesel engine, improved electric steering, and Skoda-designed running gear and tracks, changes that should improve performance but instead reveal new problems as each modification adds complexity that creates additional failure points. Testing continues through September and October 1944, with results that grow more discouraging as engineers discover that the modifications have not solved fundamental problems but simply replaced one set of failures with another. Engines still break down regularly, electrical systems still fail, the vehicle still cannot approach its design speed or range, and the cumulative effect of constant mechanical problems makes it clear that the Mouse would never survive sustained combat operations where reliability matters more than armour, thickness or gun power. Test reports note that achieving the maximum design speed requires weakening the motor field to dangerous levels that risk burning out the electric motors, meaning the tank must choose between preserving its drivetrain and achieving useful tactical speed, a choice that should never need to be made in a combat vehicle. By mid-1944, the strategic situation makes the Mouse's inadequacies even more glaring, As Germany faces Allied advances on multiple fronts, the Normandy invasion opening a new front in the west while Soviet armies push relentlessly toward Germany's borders in the east, situations that demand mobile defensive forces capable of rapid response and sustained operations, exactly the opposite of what the Maus represents. German tank commanders facing Soviet tank armies need Panthers and Tigers that can maneuver to meet threats, that can withdraw when overwhelmed, that can exploit weak points in Soviet lines, while the Maus would be a static defensive position at best, and a death trap for its crew at worst, unable to withdraw if outflanked, unable to redeploy if needed elsewhere, consuming fuel and resources desperately needed for conventional tanks that could actually influence battle outcomes. The absurdity reaches peak expression when planners calculate that building the 150 Maus tanks Hitler originally ordered would consume steel and resources sufficient to build over 600 Panthers or 900 Mark IV tanks. Vehicles that, while less individually impressive, would provide far more combat capability through numbers, mobility, and operational flexibility. Every skilled machinist working on the Maus, every ton of armor plate allocated to its construction, every kilowatt of electricity used in its electric transmission represents resources not available for weapons that might actually help Germany's deteriorating military position. The final nail in this Maus's coffin comes in October 1943, when Hitler cancels the order for 150 vehicles, reducing production to just 5 tanks, and then in November 1943, when he cancels the project entirely after examining cost projections and production schedules that show building even small numbers would be impossible with Germany's shrinking industrial capacity and resource base. But the cancellation comes too late to stop work on the 2 prototypes already under construction, and Porsche continues testing through 1944. Partly from engineering curiosity, partly from hope that Hitler might change his mind if the tests show promise. Mostly because stopping would mean admitting complete failure of a project that consumed thousands of engineering hours and millions of Reichmarks. The 2 prototypes remain at Kummersdorf, proving grounds through the winter of 1944 and into spring 1945, occasionally tested, frequently broken, increasingly irrelevant as the Soviet army approaches Berlin and the Third Reich enters its death spiral. German engineers watching the Red Army's approach face a decision about what to do with these white elephants, these monuments to Hitler's megalomania and Porsche's hubris, and they choose to destroy them rather than let them fall intact into Soviet hands, placing explosive charges in the engine compartments and turrets, detonating them as Soviet tanks appear on the horizon. But the demolition proves imperfect as Soviet troops arrive to find the 2 Maus prototypes damaged, but not completely destroyed, 1 hull relatively intact, 1 turret still functional, and Soviet engineers see opportunity in this wreckage, ordering that the V1 hull be mated with the V2 turret to create a single functional vehicle, using 6 massive German half-tracks to drag the 55-ton turret across the proving ground and mount it on the surviving hull, creating a Frankenstein's monster of a tank that the Soviets ship back to Moscow for evaluation. Soviet testing in 1945 and 1946 confirms what German engineers already knew, that the Maus is a mechanical disaster, underpowered, unreliable, tactically inflexible, operationally useless, consuming resources far beyond its combat value, and Soviet tank designers studying captured German technical documents conclude that the Maus chassis represents exactly how not to design a tank, a cautionary tale about the dangers of prioritizing specifications over operational requirements. The composite Maus eventually finds its way to the Kubinka Tank Museum outside Moscow, where it remains today, stripped of its engine and internal systems, an empty shell of armour and guns, the only surviving example of Hitler's supertank that failed before it fired a shot in anger. The story of the Maus reveals how Hitler's interference in military procurement combined with Porsche's engineering ambition created something that looked impressive in presentations but violated every principle of practical tank design, starting from the fundamental misunderstanding that a tank is not a bunker on tracks, but a mobile weapons platform that must balance protection, firepower, and mobility in proportions that allow effective combat operations. Hitler never understood this balance, constantly demanding more armour, bigger guns, heavier vehicles, assuming that sheer weight and power would overcome tactical and operational limitations, ignoring advice from tank commanders who explained that a Panther worth its weight in gold was worthless if it broke down before reaching battle, or consumed so much fuel it could not maneuver. Porsche shares blame for enabling Hitler's fantasies rather than educating him about engineering realities, designing vehicles that satisfied Hitler's demands for impressive specifications while ignoring whether those vehicles could function in combat, using experimental technology like electric transmissions, not because they were proven solutions, but because they allowed paper designs to meet impossible requirements, gambling that problems would be solved during development, rather than admitting from the start that some requirements cannot be met with available technology and resources. The Mouse's failure reflects broader patterns in late-war German weapon development, where desperation and denial combined to produce wonder weapons that promised miraculous victory, while consuming resources and attention that could have been better spent on proven systems, programs like the Maus, the E-100 even heavier tank project, the Ratte 1,000-ton land battleship concept, the monster 1,500-ton artillery carrier, designs that existed primarily on paper and in Hitler's imagination, offering him comfort that German engineering genius would somehow produce weapons to turn the tide even as Allied armies closed in from all directions. The engineers and industrialists who pursued these projects share responsibility for enabling Hitler's delusions, for not pushing back harder against impossible requirements, for not explaining more forcefully that building one Maus meant not building 600 Panthers, that resources are finite and must be allocated to weapons with actual combat utility rather than propaganda value. Some historians argue charitably that these projects represented German engineering creativity, attempts to find technological solutions to Germany's strategic problems, but this interpretation ignores that German engineers knew better, that practical tank designers like those at Henschel, who produced the Tiger and Panther, understood what made tanks effective, that the Maus succeeded only in draining resources from weapons that might have extended Germany's ability to resist. The legacy of the Maus extends beyond its immediate failure to influence post-war thinking about tank design and military procurement, becoming a cautionary tale studied in military academies as an example of how not to develop weapons, illustrating the dangers of requirements creep where each added feature seems reasonable in isolation, but cumulative additions create vehicles too complex to build and too difficult to maintain. The Maus demonstrates that armor and firepower alone do not make effective tanks, that mobility and reliability matter as much as protection and killing power, that a tank that cannot reach battle or breaks down before arriving contributes nothing regardless of how thick its armor or how powerful its gun. Modern tank designers looking at the Maus understand immediately why it failed, recognizing that weight is the enemy of tactical mobility, that every ton of armor requires more engine power, which requires more fuel, which reduces range, which limits operational flexibility, creating a vicious cycle that the Maus embodied perfectly in its 188 tons of immobile steel. The Maus survives today not only as a museum exhibit and a subject of fascination for military history. Enthusiasts who marvel at its audacity while understanding its futility, a physical manifestation of Hitler's megalomania preserved behind glass at Kubinka, where visitors can walk around the composite vehicle and appreciate both the impressive engineering that went into creating something so massive and the fundamental foolishness of building it in the first place. The tank's presence in video games like World of Tanks and War Thunder gives it a second life where players can experience what commanding this steel monster might have been like without the mechanical failures, fuel shortages, and mobility problems that made it useless in reality, creating an alternate history where the Maus's strengths matter and its weaknesses disappear, letting people appreciate the design while safely ignoring why it never worked. Military historians comparing the Maus to successful tanks like the T-34, the Sherman, or even Germany's own Panther recognize that effectiveness comes not from extreme specifications, but from balanced designs that troops can maintain in field conditions, that logistics can supply, that industry can produce in useful numbers, qualities the Maus completely lacked. The final irony of the Maus project is that it consumed resources during Germany's greatest need, drawing skilled engineers away from projects that might have helped Germany's war effort, using steel that could have become conventional tanks, burning fuel for tests that could have supplied combat units, all to produce two prototypes of a vehicle that everyone involved knew would never see mass production or combat deployment. The project continued despite its obvious futility because Hitler demanded it, because Porsche pursued it, because the industrial and military bureaucracies of Nazi Germany lacked mechanisms to stop programs that had Führer support regardless of their practical utility, creating a system where resources flowed to weapons that impressed Hitler rather than weapons that won battles. This pattern repeated throughout late war Germany, with jet fighters that entered service too late and in too small numbers to matter, rockets that consumed resources without strategic impact, submarines so advanced they barely left port before war's end. all products of a system where political pressure trumped military necessity and engineering ambition exceeded industrial capability. In the final analysis, the Panzerkampfwagen 8 Maus stands as perhaps the clearest example in military history of a weapon that failed before it fired a shot, defeated not by enemy action, but by its own impossible requirements and the flawed procurement system that brought it into existence. The 188 tons of steel and guns that Soviet engineers assembled from the wreckage of 2 prototypes represents billions of Reichsmarks spent, thousands of engineering hours consumed, precious resources wasted, all to produce a tank that could barely move, that broke down constantly, that could not deploy effectively, that would have been a death trap for any crew unfortunate enough to operate it in combat. Hitler's super tank broke itself through the simple physics of trying to move too much weight with too little power, through the complexity of systems that multiplied failure points, through design choices that prioritized impressive specifications over operational utility, through a development process that never seriously questioned whether the whole concept made sense. The Maus, the heaviest fully enclosed tank ever built, survives today not as a triumph of German engineering, but as a monument to the folly of designing weapons to satisfy political vanity rather than military necessity. A cautionary tale preserved at Kubinka for future generations who might otherwise repeat the same mistakes, believing that bigger always means better, and that engineering genius can overcome fundamental limitations of physics, logistics, and common sense.